So what we're going to do is compare bit strings. And a bit string is just a sequence of ones and zeros. And the way they're handled in computer science is that ones represent a true, usually. Of course, they can also represent actual numbers, as we're going to find out later in this course. But when we're talking about them bit by bit, true is considered a 1 and false is considered a 0. So in order to compare two bit strings, they have to have the same length. And you notice that there's a space between, they're in groups of 4. That's just how we typically write bit strings out because otherwise they get really hard to read. So in order to compare the bit strings, we apply the same principles as before. An and means they both have to be true at the same time in order to be true. An or means one of them has to be true in order to produce a true. Exclusive or means if they're both false, you end up with false. If they're both true, you end up with false. And if they're mixed, you end up with true. So just as for example, so if I have a 1 and 0, that turns into a 0. If I have a 1 or a 0, that turns into a 1. And if I have a 1 exclusive or 0, that turns into 1, just to name a few. So I'm going to write out the bit strings here. So this is A, and this is 1, 1, 0, 0, 0, 1, 1, 0. I'm writing them this way so that we can easily compare. So I'm going to start here comparing that bit to that bit. So the and I'm going to draw the line here. So I have 1 and 1, which is 1. So there we go. So 0, 1 is 0, 0, 0 is 0, 1, 0 is 0, 1, 0 is 0, 0, 1 is 0, 2 1s is 1, 1, 0 is 0. So this is A and B. Now, glimpse into Boolean algebra, this is also written as AB because you notice if you multiply the bits together, the only way you're going to get a 1 is if you multiply a 1 and a 1, otherwise you're going to get a 0. So that's where the Boolean algebra comes in. But not a lesson for today. We're just comparing bits. As far as the OR goes, remember that all you need is a presence of a 1 in order to end up with a 1. So I'm not going to write these down again, but comparing bit by bit, 2 1s make a 1, a 0 and a 1 make a 1, a 0 and a 0 make a 0, a 1 and a 0 make a 1, a 1 and a 0 make a 1, 1, 1, 1. And this is A or B. And technically, with a little bit of modification, this is what we call A plus B. Okay, and there's that. Now, XOR, remember, if they're both true, you get a 0. If they're both false, you get a 0. And if they're mixed, you get a 1. So that means XORing a 1 and a 1 gives you a 0. 0, 1 gives you 1. 0, 0 gives you 0. So another way of thinking about XOR is if they're the same, you get 0. If they're different, you get 1. So there we have it. 1, 1, 0, 1. And I don't really have an operation for that now, at least nothing that's really useful right now. So there is how you do the bitwise comparisons, ands, ors, and XORs for bit strings. Thanks for watching.